Hello, my name is Paul Vanden Branden and I work for SciMed. And today's video is going to be to introduce the Collo Probe, a novel and unique tool to allow you to fingerprint your liquid, gels, anything that flows, and allow you to either fingerprint or do some batch-to-batch checks. So please follow me into our laboratory and let's get on with some simple experiments to illustrate how the Collo Probe can be used and how sensitive it is. Please follow me. Well, here we are in the SciMed laboratory, ready to show you the Collo Probe. And here it is, the Collo Probe, very simple device, very robust, ruggedly designed, currently immersed in some water so we can generate some kind of a baseline to help us to compare with. So the Collo Probe is essentially all about the black circle on a sensor here, which will generate an electromagnetic field, and the sample it's immersed to will then generate a dielectric response. And it's that response we're going to measure, and it's that response that's going to help us fingerprint the actual sample. And the whole idea is that this dielectric response can detect changes of all sorts, from concentrations, presence or absence, or quality of product. And therefore, why we call this Collo Probe a fingerprinting tool, because it will be able to uniquely identify a product versus its competitors, versus counterfeits, but also be a great tool to do a batch-to-batch check. And potentially where quality control of the liquid is difficult, it will be able to give that fingerprint of where it is compared to the benchmark batch that was made on day one. So an ideal tool for all sorts of measurements without creating any complication in what it does. And on this video, we're going to give the simple example of measuring 4 different types of milk. And we're going to compare the 4 milks based on the Collo signal. Now, there are 2 main parameters that are measured by the Collo Probe. One is the Collo Permittivity, and the second is the Collo Ion Viscosity. These are the 2 signals that we're going to measure back. The Collo Permittivity is usually good at detecting changes in things like fat content, oil content, essentially variations in organic content. Whereas the Collo Ion Viscosity will more respond with the ionic charges of the samples as it receives the electromagnetic field. So what we're going to find out today is, well, first of all, which signal responds the most to the changes of milk types, and so on and so forth. So without further ado, I shall take what is defined as a whole milk, and I'm simply going to take the water out and replace with the milk. And as you can see, there's an immediate step change in the signal. And if we look at the graph at the moment, what we can see is the Collo Permittivity has significantly changed, as well as the ion viscosity. So that's what you would expect as you go from water to milk. And in order to start seeing some more meaningful data, I am now going to swap from a whole milk to a semi-skimmed milk and see what data change we get. So immersing the semi-skim milk now. And as you would hope, there is another step change in the data we are generating. And we can see that the permittivity has changed, as well as the viscosity. Interestingly, they've changed in different directions, but that's just due to the nature of the signal they're detecting. So after a few more seconds of measurement, I will simply now take some skimmed milk and replace it from the semi-skimmed milk. Okay, just to raise the probe a tiny little bit more. Here we are. It doesn't need to be fitted on the stand, but the purpose of this video is certainly a simple way to do it. So here we are. We now have a skimmed milk sample. And what's really interesting, we can see another step change in the data, both in permittivity and in ion viscosity. And the change is going in the same direction, which is what you would hope, since probably the main change in this between the samples is the fat content of the milk. So we are seeing a constant change. So potentially very useful data for milk producers. But do remember, this video is using a simple example of milk. It can be applied to anything from a gel up to a water sample and anything in between. We're talking paints, we're talking chemicals, we're talking liquid, pharmaceuticals or medications. We're talking wines and spirits. It's very good at identifying the quality of a wine, even if a wine is fully uncorked, and maybe we'll do another video on that at some point. But for today, we're just using milk as an example. Now, interestingly here, a final sample is an oat milk. And we can see here a big jump in data. Clearly, by nature, oat milk is very different to dairy milk, and that is directly illustrated in both the permittivity and the ion viscosity. So very clearly, the Collo Probe has immediately distinguished this from all the other milks, which is exactly what we hope for. So here we are, a very simple illustration of what the Collo Probe can do, using milk as an example. Now, there are two more sets of data that can be derived with the software. The first one is what's called the 8 senses plot, which presents the data in a spider diagram. And then the other one is a 2D plot, which shows the permittivity versus the ion viscosity. And as we can see, with all of this data, with all of these representations, we can see that we get some very useful data. And what's really important is we can distinguish these samples. So whether you are a milk producer, whether you are producing gin, whether you're producing washing up liquid, this Collo Probe could be useful to you as a fingerprinting tool or as a batch-to-batch checking tool. Below, at the bottom of the screen, are our contact details. We would love to try our Collo Probe on your materials. So do get in touch. We can bring it to you, we can try it with you, so we can see what together, whereas the Collo Probe is a useful tool for yourselves. So do get in touch, contact details at the bottom of the screen, and hopefully we'll be hearing from you soon. Thank you very much for watching this video.